Hello everyone, this is Wasim from Edureka and I welcome you all to this session in which I am going to talk about data science projects that you should work on to get a job. Let us take a look at the agenda for this session. So first of all, I'm going to start with the basic introduction to data science life cycle, and then I will explain the project objective for this session. Moving further, we will work on visualization for analysis, and finally we will work on COVID-19 Italy data to understand how we can work with data science project for beginners. I hope you guys are clear with the agenda. So meanwhile, don't forget to subscribe to Edureka for more exciting tutorials and press the bell icon to get the latest updates on Edureka and enroll to Edureka's Python for Data Science certification program. The link is given in the description box below. Now let us begin our session. I will not take long before we begin our project, but I want to just quickly tell you a few basics that we have to, understand to approach any data science project for that matter. So first of all, I'm going to talk about the data science lifecycle. The data science lifecycle includes the processes like collecting the data, extraction, or loading it into your program. And when the data is loaded in the program, you have to clean the data, manipulate it according to your requirements, and then you have to draw conclusions or understand the data throughout by visualization to understand the relation between the different plot points of your data. So these are the processes that are included in your data science lifecycle. After you have enough conclusive relationship between the variables, you are able to understand what kind of model you can approach this data for. Then there comes model selection, and then we move on to the model building and deployment. So as a beginner, I think you should start with the very basic of the data science lifecycle. So the first project in this session will be drawing conclusions by data visualization. For that, let me just tell you as a beginner, what kind of projects should you take for practice. So first of all, you have to keep in mind that the projects that you're taking are going to cover all the aspects of the data science lifecycle. That is collecting the data, getting the correct data from the source that you're downloading it from or you're extracting it from. Then you have to make sure that you understand the data. You're able to clean the data of the redundancies or any missing values for that matter. Then you should be able to relate it to such a level that you can visualize it on a graph so that you'll be able to understand it better. So when you have reached that point, you have actually mastered quite a few skills in data science. So after you have mastered until that point where you can actually visualize the relationship between the variables, you can move on to making the model, and there comes the picture which is machine learning, and you can move on to advanced concepts like AI and everything. But before that, you have to keep in mind that you should master the basics first. So my suggestion would be you should start with the projects which will help you understand the first few processes in the data science lifecycle. So you can start with any data, you can pick up any data on Kaggle and you just download it, try to understand the relationship points, make a few visualizations, and that is what we are going to do in this project as well. After that, you can choose other data which is kind of categorical in the sense because you'll be able to make regression or you can make a prediction or you can predict the outcomes in that data if the data is categorical in nature. Otherwise, there's no problem. There are a lot of classification algorithms that we have in machine learning we can use on a model. So we're going to begin now. I'll just quickly tell you what kind of data we are dealing with here. So we have a COVID-19 Italy data from the past month. I am sure everybody is aware of the pandemic that we are facing right now. I mean, it's been all over the world. People are suffering from it, and it's a very tough time for all humanity. But in the wake of it, we can actually do something productive. In spite of being at home, we can learn stuff. So I was able to find this data on Kaggle. So this is a Italy data for the past month, and we're going to read, understand the data, and we're going to use the visualization libraries like Seaborn to understand the relationship between various aspects of the data. So we're just going to move on to Jupyter Notebook, guys, and we will see what we can do there. And I'm choosing Jupyter Notebook because it is very easy to work with Jupyter Notebook when you're working in data science. And most specifically, if you're working on visualization, Jupyter Notebook is the best deal you have right now. I mean, you can also work on other IDs like PyCharm and everything, but this is quite good when it comes to, just putting something over here and executing it at your fingertips. That's pretty cool. So I'm going to use Jupyter Notebook in this session. And I'm hoping everybody is familiar with Jupyter Notebook. And if you're not, we have a full tutorial on how you can get familiar with Jupyter Notebook, how you can start the installation part. Everything is covered in that. You should check that out. I'll just put the link over there. And you can also check out the cheat sheet, all these tabs that we have over here, what all these tabs do. So first of all, what we have to do is import the dependencies that we have. So for that, I'm just going to import. First of all, I'm going to import pandas, all the necessary libraries that I think are going to be dependency problem over here. I'm just going to import all of them. And for visualization in this session, I'm going to use 𝐶born, guys. So I'll import 𝐶born as SNS. And to be on the safer side, I'm going to import matplotlib.pyplot as PLT. So I'm going to run this, and we have, I think we don't have any errors. So it's going to take a while. Meanwhile, I'll just write the code to import the data or read the CSV data that we have here. So I'm going to use pd.read CSV, right? And then I'm going to mention the file location. It should work fine, or we just add R over here to avoid any errors. Right, we have successfully imported the data. Now we are going to look at the data for the first time. We'll see what the data looks like. Okay, all right, we'll just take a look at the first 5 rows first. All right, so we have all these rows and columns. All right, so we have date. Okay, we'll just get the list of all the columns. So we have one unnamed, we have date, state, hospitalized with symptoms, we have intensive care, people in the intensive care, the total hospitalized people, home quarantine people, we have total confirmed cases, new confirmed cases, the people who have recovered, the number of deaths, unfortunately, and we have total cases, the swabs made, noted, and note N as well. So this is our data, guys. I'm sure most of you will be able to do this without any hassle over here. After this, the real part comes. You have to take a look at the data again. Just keep in mind, like, this is exploring the data, trying to find out what exactly it looks like. So we have date, all those dates, it's in the date format. Then we have state, the people with hospitalized with symptoms. So the 34th entry has more than 27,000 people with symptoms, intensive care, and everything we have. On the first day when it is recorded, people with symptoms were 101, 26. So we'll try to figure out a relationship between all these variables, or we can say all these instances in this data frame that we have over here. So let's just take a look at the data. So we can use this data.describe method. It's going to give us certain values. Okay, so it's going to give us the count, the mean, the standard deviation, the minimum, all these values we can take care of. So this is basically used when you are trying to fill in the null values or the missing values in your data. I mean, this is a very short data, so we're not supposed to make any changes to the null values because it can create a lot of ruckus in your visualizations. We're just going to leave it like that. So I'll just tell you how you can check for null values as well. So you just write data dot, let's say, is null. All right, I'm gonna get the sum of all the values that are null over here. So we have noted and note N, which is we have 27 values which are null from out of 34 values. So if I drop all these columns, my data will not be left with any values. I mean, I don't need 7 rows in my data because that's not going to be enough to make conclusions. All right, even now it is not enough data to make conclusions. We're just going to take a look at how we can visualize these relationship between these variables. So we're just going to jump right to it, and we are going to take a first look at our first visualization that we are going to do. So what I'm going to do is I'm going to relate the variables using the scatter plots. So I'll just give it a heading, guys. Not this one, okay. I actually don't want this to be a heading. This I want to be a heading, guys. Okay, so this is a level 2 heading. I'm gonna just relating the variables with scatter plots. So what exactly I'm going to do here is the scatter plot is a mainstay of statistical visualization, and it basically depicts the joint distribution of two variables using a cloud of points where each point represents an observation in the dataset. So the depiction allows the eye or any user that is looking at it to infer a substantial amount of information about whether there is any meaningful relationship between them. So I'll just use SNS dot relation plot because we're checking the relationship with scatter plots. So I can use rel plot, or basically I'm just going to use this only. So I'll mention X and I'll mention Y. I'll tell you what are these values. Data is equal to data. Now from my data set, I want to check the relationship between the total cases. Okay, all right. We'll just put one command over here. All right, this is code. Okay, I just want the name of the column, so I'll just write data is null dot sum. Where I'll just get the columns only. All right, so we have all these column names, labels, we can say that. So I want to check the relationship between, let's say, the total cases, and I want to check people who have actually recovered. All right, so we have a relationship over here. So as you can see, on the x-axis we have the total number of cases, and on the y-axis we have the number of people who have recovered. So when I look at the data over here, for the initial 20,000 total cases, there were not a lot of people who had recovered, less than 2,000 people. But then as the number grew stronger, I mean it grew a lot more than let's say 100,000, people actually recovered more. So if you take a look at total number of cases reaching 100,000, more than 12,000 people have actually recovered. So this is a brighter side, guys. Like, people are actually recovering from the disease, and this is a linear relationship. So this is a good conclusion that we make looking at this relationship over here between total cases and recovered, that people are actually recovering from the disease in Italy in the last 34 days. So we'll make one point for the conclusion, that is, people are recovering. Now we'll take a look at the next graph, or we'll take a look at a different perspective of this graph plot. So we want to check the total cases. Let's say how many people have actually died from it. Okay, so deaths are also going in the same direction with the recovered people. Like, more than 10,000 people have actually died from the disease in the last 34 days in Italy. And if you look at the number in starting, the number was actually pretty high, and it has grown to a level comparatively equal to how many people have actually recovered. There were more than 12,000 people. The deaths are actually more than 10,000 people. So that is the scarier part, guys. So we have to do our part and stay at home when the government tells us to. Now we want to check the relationship between total cases and total confirmed cases, let's say. And just to tell you guys again, this is just an introductory project for you guys. There are going to be two more sessions where we'll be performing predictions, and there'll be a session about fraud detection in a credit card. So we'll be doing that also. If you think this is a very basic concept for you guys, I'm sure you can work this as an exercise to brush your skills on your knowledge, guys. So bear with me. So everything is actually going in the right direction over here. So everything is actually increasing exponentially in this data set, guys. So from when it started from 0, and then it has reached more than 70,000 people, the total number of cases, which is actually a very sad part to look at. Out of all the 100,000 cases, more than 70,000 people have actually confirmed the case. And let's say we want to check the people who were hospitalized with symptoms, and the number between the total number of confirmed cases. So there's a slight curve over here when the number reaches 40,000. So let's say people who were hospitalized with symptoms are more than 25,000, and the total number of cases have reached more than 70,000. Okay, we're just going to change these. And let's take a look at hospitalized with symptoms. Okay, so now we can see that the people who are hospitalized with symptoms are reaching more than 25,000, but the total number of cases are much more than that. So it does not necessarily mean that if you have a symptom, you're not gonna catch the virus. Looking at this data, so be careful, guys. And let's take a look at the next one, or the next aspect, where we can actually add the hue as well. So for hue, let me just add recovered. Right, we have a syntax error. Let's see what this tells us now. So we have added the hue. All right, so we have recovered starting from 0, then we have 5,000, 10,000, and 15,000. So all these plot points that I'm telling you are to understand the relationship between all these variables that we have. And also we can also have this pay plot. Okay, so I'm just gonna show you this, what happens if I do that, if I get the pay plot. So what exactly is going to happen is it will tell us a lot of stuff about what is happening over here with these variables between. It's gonna give me a picture of the whole picture of the data set with the relationship between each other. We'll wait for that. And meanwhile, I'll tell you the next pay plot, or the next plot that we are going to work on, which is basically going to be emphasizing the continuity with line plots. So we'll take a look at line plots also. And let me just tell you, like, scatter plots are highly effective, but there is no universally optimal type of visualization. So instead, the visual representation should be adapted for the specific of the data set and to the question you are trying to answer with the plot. Like if I have a question, I should be able to answer that question looking at the visualization or the plot. So what I'm going to do is with some data sets, you may want to understand changes in one variable as a function or a similarity continuous variable. In this situation, a good choice to draw a line plot. So in Seaborn, we can accomplish this by line plot function, or we can just use rel plot, and in the type or the kind, we can write line. All right, guys. So we'll wait for the output, and then we'll take a look at the next plot that we are going to work on. So the diagram over here in this pay plot that we are getting is pretty complicated. So we're going to skip this part and we'll move on to the next one that we have, which is we are going to work with emphasizing the continuity with line plots. So what I'm going to do is I'll just write sns.rel plot only, and we're going to provide x, we'll provide y. There has to be a kind in which we're going to write line, and then data is equal to data. So for x, let's say, okay, I'll add a right, I'll add data dot columns so that you can take a look at the columns again before making any plots. So let's check for people in home quarantine, and for y we want to see, let's say, total cases. All right, so we have a error, guys. Plot kind line is not recognized, so I'll just write as line. Okay, so this is the relationship between the home quarantine and total cases, guys. Okay, so if I just swap it, so this is going to be my total cases, and let's see, quarantine, or which is home quarantine. Right, so there is some error, guys. All right, there's a spelling mistake, I'm sorry, guys. Okay, so the total number of cases is probably around 100,000, and the home quarantine people are more than 40,000 people. So all these people, if you guys stay at home, we can actually flatten this curve and make a dent in the total number of cases. So we can draw one more conclusion from over here is that is, if more people are in quarantine, the total number of cases is going to be very low. Instead of total cases, let's see recovered. Right, so it is actually started from 0, and the recovered people reached 2,000 pretty easily, and in the home quarantine people, when they were 10,000, more than 4,000 people had recovered. So this is the bright side, guys. And similarly, we can also check for other relationship between intensive care, like people with intensive care, and all these plot points that we have inside this data set. After this, let's take a look at how we can actually plot a few graphs using the categorical scatter plots. So the default representation of the data in cat plot uses a scatter plot. So we're going to use the cat plot, guys. There are actually two different categorical scatter plots in 𝐶born. So they take different approaches to resolving the main challenge in representing categorical data with a scatter plot. That all of the points belonging to one category would fall on the same position along the axis corresponding to the categorical variable. So the approach used by the cat plot is to adjust the positions of points on the categorical axis with a small amount of random jitter. So it's simple, guys. I'm just going to provide a few values. Okay, we'll just add a right. So we're going to provide x, give it some value, let's say total cases, y is equal to, okay, so let's just say recovered data is equal to data. So let's see how the plot looks like in this. All right, so it's actually pretty haphazard. So instead of, okay, it has to be a categorical plot. So either they have recovered or they have not. So we're getting these for all these values. So we actually don't have any other categorical values in this data set. So we have stayed hospitalized with symptoms. None of the cases here are categorical, but we can actually make a dummy value for recovered and death. So for doing that, we can actually make new data frame with dummy values where we have recovered and death so that we can work with the categorical plots as well. But to do that, we'll have to make a few changes to the data set. But instead of that, let's move on to the next, because we don't want to complicate this because you're a beginner. So we'll just use another method. So inside which we're going to use the distributions of observations within categories. So we'll just plot some more graphs to understand the relations. It's clearly we can see the number of cases are rising and all the other, like we see over here. So none of this is actually going down. Everything is going up. You compare anything, the deaths are going up, the recovered patients are also going up. So that's the brighter side. So that is the conclusion that we can draw from this project that we have done over here with all these graphs that I've plotted. So we had our data, guys, in which we had all these values for hospitalized with symptoms, people in the ICU, the total hospitalized people were there, and the home quarantine people were there, the total confirmed cases, the new confirmed cases, and the people who had recovered, the number of deaths, the total cases, all these values we had in the data set that we had. And on the last day, the 34th entry shows the people who are with hospitalized with symptoms are much more than 27,000. So we can look at the number over here. But let's say this data is new to somebody and who does not have any idea about this data. So how is he going to interpret what is happening over here, and like how has the disease spread over all these days? So to do that, the simplest thing is to make visual representations through 𝐶born, or you can use matplotlib as well. So we did that, and we were able to conclude that the number of people who had recovered is also increasing at a very rapid rate. So that is the best bet that we have against this virus, looking at the data. And of course, number of deaths are rising, the number of cases are actually very much, and they are rising again. So that is what we have to control. So the people all around the globe, the people who are trying to tell you to stay home, stay in the quarantine, are actually trying to bend the curve, the total number of cases. So that is going to happen if you stay at home, and number of people who are recovering is also increasing. And if the number of people in the hospitals increase, there is a chance that people will not get better treatment because of the shortage of supplies. So that is the conclusion that we can draw. So the three main conclusions that we can draw from this observation that we have done in this project is that the people are increasing in recovery with the total number of cases, of course. The second conclusion would be we need to work on flattening the curve of total number of cases. So if we look at this one, the total confirmed cases and hospitalized with symptoms, we'll make it here. So X is, let's say, total cases and total hospitalized. So this we have to flat the curve, guys. So you can actually see flattening the curve here when the cases reach 40,000 cases, the total cases, and the number of people hospitalized were actually flattening. So this is what we have to flatten, guys. So we don't want more number of people to be hospitalized, and we don't want total cases to actually reach the heights that would be devastating. So you have to take the measures. So this is one conclusion that we can make. So we have to keep in mind that total hospitalized people, the quarantine people, the people with more number of cases will not be reported. So this is the second conclusion that we can make. The third conclusion is the number of deaths are also increasing, and we can see somewhat the curve shortening or the curve flattening over here. Some cases it's increasing, some cases it has decreased to some extent, but we need it to stop. So stay at home, guys, listen to what the government has to say, and stay tuned for the next session that we have, in which we are going to perform a prediction using Python. And now that we are done with the basic project to start with, we have covered the first few processes in the data science lifecycle. I did not show you how to gather the data that you can do on Kaggle, guys. You can just search for any data set that you want, go there, download it, and you will be good to go. After that, you save the file, and to import it or to load it into your program, you just have to give this command, which is pd, which is an alias for pandas. You use the read CSV method. Inside this, you provide the location of your dataset with the file name .csv extension. You'll be good to go there. And if you find any errors, try with this one. First of all, you add R over here. I'll just show you what kind of error you get if you don't add that. Sometimes I'm not getting that error, but sometimes you will get an error, truncated error. So just add R over here. You won't get that error. So that covers the loading your data set into your program part. Then looking at the data we have covered, like the first 5 rows we can check the last 5 rows, we can check the columns, we can check or describe the data, get the count, the mean values, the standard deviation, the average, the maximum. All right, so we have a mean value. Let's see for deaths how many. All right, this is quite high, this is very overwhelming, guys, and the total number of cases also. Okay, so after that we have made a few visualizations using the seaborn library. And if you want to check out more number of plots that you can actually make, you should check out the 𝐶born's official documentation. They have a very good tutorial, and we have also made a 𝐶born library tutorial on YouTube. You can check that out as well. And in the next session, we will work on linear regression to predict an outcome using a data set. If you have any questions, tell us in the comments section. Thank you, guys. See you in the next session.